Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problem number 1 of the 2004 AP Calculus AB free response question, focusing on flow rate. All right, let's take a look at question 1. It says, traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by this function right here, where f of t is measured in cars per minute and t is measured in minutes. To the nearest whole number, question in A part, how many cars pass through the intersection over the 30-minute period? So basically, we're looking for the amount of cars that passes through the intersection. Okay, so before we solve the problem, let's take a look at the formula that we're going to be using to solve this problem. Okay, now whenever you're working with rate and amount of quantity that flows using that rate over a period of time, think about art. Okay, the word art. So amount, total amount, is equal to rate times time. This formula applies to a scenario where you have a constant rate over an interval, then you can just simply multiply it because the area underneath the curve, the rate curve, will basically tell you the amount over that interval, okay? But if you have a variable rate like this, okay, this is not constant, it's a variable rate, then we have to use calculus. That's when calculus comes into play. Okay, so this formula now takes the form amount is equal to the integral from a to b of the rate times dt. We're just going to slice the entire region into really infinitely narrow rectangles, and then we're going to accumulate the area over the interval. Okay, so that's the beauty of calculus. We can calculate areas underneath regions with where the function is a variable function. Okay, so the formula is the total amount. Total amount is just like the A is that's from A to B is equal to the integral from the starting time to the end time of the rate. Okay, rate as a function of time times dt. So that's the formula that we're going to be using here. Okay, now let's go ahead and apply this formula to the scenario that we're dealing with right here. So before we do that, let me just label this clearly for you. This is the flow rate. Okay, so total amount of cars, amount of cars from, we're going from 0 to 30, is going to be what? It's going to be the integral from the start time 0 to the end time of 30 of the flow rate function, the rate function, which is f of t dt. Okay, now this is a calculator active question, so we're going to be using our calculator to compute the value of this definite integral. Now, since we're going to be using this flow rate function multiple times in question number 1, what is a smart thing to do in order to save time and reduce the chances of making mistakes? We want to store this function, right? We want to store this function in our calculator. So let's go ahead and do that. So we're going to enter 82 plus 4 sine t over 2. We're going to take this function and we're going to store it in f of t. Okay, so let's do f of t. F, where are you? So you just use you can make it uppercase, but I'm just going to use lowercase. F of t doesn't really matter. Just stick to whatever variable you're storing it as. Enter. Okay, so I've stored this in f of t. Now let me make sure that this function is in fact stored there. So I'm going to type in f of t and press enter. Now we have it stored. Okay, so now I don't have to enter this function anymore. I can just carry out any computations involving f using f of t. Okay, all right, so for this particular problem, we're evaluating the integral from 0 to 30 of f of t. Okay, so we're going to go second function 7, the integral of what's the function. Let me just move my cursor up and hit enter just to copy it down to save time. What is the variable of differentiate? I'm sorry, integration. We're integrating with respect to t, okay? Let the dummy variable guide you. So it's t, comma, lower limit of integration is 0, upper limit of integration is 30. Press enter. Well, this is the exact answer. I need a numerical value. I'm on enter. Okay, so you get that 2474.08. So 2474.08. 2474.08. In the problem, we're asked to round it to the nearest whole number. So what do we have? We're going to be rounding it down since you can have fractional cars. So we're going to have total of 2,474 cars. As the answer for question 1A, don't forget to box your answer so it's easy for a grader to know what your final result is. And then for this problem, you earn a total of 3 points. Okay, you get 1 point for the limits of integration. You get another point for the integrand. So what on earth are you integrating? And then you get 1 point for your final answer. All right, so the setup earns you 2 points, and then the final result earns you your final point. Okay, so actually this is the answer right here because you were asked to round it. So that's not the final answer. This is the final answer. Nicely rounded, total of 3 points. Now, what this problem teaches you is that you want to show all your work. You want to include your setup in the question on your answers document. Don't just enter it in the calculator and then write this answer. If you do that, you run the risk of getting only 1 point, or you might not even get any points at all. So always write all your work, including your setup. Whatever setup you're entering into the calculator, like we did here, you must write it on your paper so that you earn credit for that question too. All right, let's take a look at the B part. It says, is the traffic flow increasing or decreasing at t equals 7? Give a reason for your answer. Okay, so traffic flow, what exactly are we looking at here? So you have to be able to accurately um, substitute the right function for what's asked in the question so that you don't solve the answer for find a solution to some other problem. Okay, so traffic flow is basically f of t by definition. So the question is asking, is f of t increasing or decreasing at t equals 7? So what tells you the behavior of a function? So I call this behavior. What tells you the behavior of a function? So we're going to write down the rule that connects a certain property of a function to its behavior, and then we're going to apply it to this scenario. Okay, so this is the rule. Just a mnemonic device to assist you. We can use the heart of calculus, f prime, and f double prime, plus minus, okay. Increasing, decreasing, increasing, decreasing, and then we have concave up or concave down. All right, so this basically gives us a visual connection between the sign of the derivative of a function and the behavior of the function. Okay, so we were talking about what determines if the function is increasing or decreasing. So if the derivative is positive, the function is increasing. And if the derivative of a function is negative, that means the function is decreasing. Okay, so let's use that to write down the rule. So we have, let's see what we have. The rule is f is increasing when its derivative is positive, okay? And f is decreasing when its derivative is negative. Okay, so in this problem, we're looking for the sign of f prime at t equals 7. Okay, so let's write down that note. The sign of f prime of f prime of 7 determines its behavior. Okay. All right. So all we're just going to do is just evaluate f prime of 7 using our calculators. All right. So some things you want to keep in mind when you're evaluating the derivative of a function at a particular time. Whatever tools you're afforded to use determines how you approach the problem. Okay, so let's do a real quick review. Let's say you were asked to find that and you were doing it by hand. How would you go about finding f prime of 7 by hand? First of all, you find the derivative of the function, okay, and then you evaluate the derivative at 7. Okay, you do your calculus first before you do any arithmetic. Okay, what if you're doing it with a calculator? As we're doing in this problem. If you're doing it with a calculator, you can condense the two steps into one. Okay, all you simply do is you enter the derivative of f of t, and then you evaluate that result at the particular t value you want to find the derivative at. So d the t of f of t evaluated at t equals 7. Okay. So what I'm just trying to emphasize is that this expression right here involves two operations condensed or written as one. Okay, you're differentiating and then evaluating. And there's a particular order in which the steps should be executed. You differentiate first and then you evaluate second. Okay, because students sometimes they switch the order. They plug in the value into a function and then look for the derivative and they get 0, and that's wrong. Okay. So what we're going to be doing, we're going to be using the second approach here. We're going to differentiate f respect to time, and then we're going to evaluate the result at t equals 7. All right, let's go ahead and input that into our calculators and see what we get. All right, we already have f of t stored in our calculator, so we're just going to type in the derivative. Let me look for f. I'm just going to scroll up to f, enter, that copies it down. We're differentiating with respect to time. Okay, so put the t there. So if I just enter this, guess what's going to happen? It's going to give me the derivative. It's going to carry out step number 1 here. Okay, but we're looking for the derivative at a particular value. So we're going to evaluate, use the bar right here underneath the equal sign at t equals, what I do? T equals 7. Okay, and then we enter, oh, that's the exact answer. We're looking for numerical results. Diamond enter. Okay, negative 8.729. Okay, so our answer is going to be negative 1.8729. All right, so you have to remember that your answer has to be accurate up to 3 decimal places, okay? I advise my students to use 4 decimal places just for safety reasons. So, and then don't forget, you never want to round intermediate answers. You want to store it in a calculator or in a variable and round only final results. Like this one, for example, so final results. So I can round it to the 3rd place or truncate it at the 3rd place. That'll give me full credit, but just use 4 decimal places just to be on the safe side, okay? Okay, so now we know what the derivative of f is at 7. So how does this help us? What are we looking for initially? We're looking for the sign of f prime of 7. Okay, so we found out that it's negative, okay? So since f prime of 7 the derivative of a function at 7 is less than 0, so what? Is the function increasing or decreasing? So the rule is if f is increasing when the derivative is positive and decreasing when the derivative is negative. So the traffic flow is decreasing on this interval. So the traffic flow is decreasing. Okay, so for this problem, let's put our answers first. You're gonna earn a total of 1 point by answering the question, stating that it's increasing, and by providing the reason. So this is the reason right here, and that's the answer. Both of them together will earn you a total of 1 point. All right, let's take a look at the C part. It asks, what is the average value of the traffic flow over the time interval 10 less than or equal to t less than or equal to 15? Indicate units of measure. Okay, now before we start, let's take a look at the formula for computing the average value of a function. Okay, so let's look at the formula. The average value of f is always on an interval, okay? From a to b is 1 over b minus a. The width of the interval, you're basically taking the area, which is the integral from a to b of the function, and you're dividing it by the width, so you get the height. That's what you're doing, okay? All right, so in this problem, we're looking for the average value of the traffic flow. So what is a traffic flow? We got to make sure that we're using the right function, okay? The traffic flow is f of t. So we're looking for the average value of f of t. All right, so let's write that down. The average value of the traffic flow, which is uppercase F, average, from 10 to 15. So in this case, A is 10 and B is 15, okay? So we're going to look at 1 over B minus A, which is 1 over 15 minus 10 times the integral from A to B, 10 to 15 of the function. The function, or the integrand in this case, is the flow rate function, the traffic flow function, uppercase f of t dt. All right, before I enter this into my calculator, let me simplify this fraction right here. So 1 over 5 times the integral from 10 to 15 of f of t dt, okay? Now let's input this expression into our calculators. So we're looking for the integral of the function. Let me just copy it. I'm being lazy here, but it's okay. So copy down the function. Variable of integration is t. Lower limit of integration is 10. Upper limit of integration is 15. Close that. Diamond enter. Bam. Okay. All right. So I deliberately made a mistake in this problem. Do you see what mistake I made? This is a mistake some students might make when you're calculating the average value of a function. So if you look at what we're supposed to evaluate right here, look at what I entered. Something is missing. What is missing is this 1 over 5. Okay, so don't forget that component anytime you're calculating the average value. All right, so I'm going to insert that right here. Just put parentheses 1 over 5. Or you can divide the answer we just got divided by 5, the same thing. So diamond enter to get an approximate result. 81.8992. Okay, so the significant figures were not stated here, so I'm just going to carry out to 4. So 81.8992. So that's going to be 81.8992. Okay, we were asked to indicate the units of measure. So that's going to be part of the solution. Okay, so what's the unit here? So whenever you're confused about units of measure, you can always use your the formula, the expression that you computed the result of to determine what your unit is going to be. Okay. All right, so let's go ahead and break it down, see if we can make sense of what's going on here. So we have 1 over b minus a 1/5 times the integral from 10 to 15 of f of t dt. All right, so what on earth is this right here? B minus A, what is 15 and what is 10? Those are time values. So the denominator here is carrying a unit of minutes, okay? So we have 1 divided by minutes. Now, what's the unit of this integral expression? Remember we talked about arcs, right? That amount is equal to rate times time. So we have a rate times time. So this is the amount of cars, total amount of cars from 10 to 15. And that's just going to be cars. That's no number of cars. Okay, that's the unit. So if you multiply this across, your answer, the value of the unit is going to be cars per minute, or cars divided by minutes. Okay, so that tells us that the unit for the average value is cars per minute. All right, so there goes your final answer. Let's go ahead and box it. Okay, so how is this problem graded? Well, you earn 2 points for setting up this integral expression correctly. Okay, you get 1 point for the integrand, and then you get another point for your limits of integration. And then you get the final third point for writing down your answer with the correct units. Total of 3 points for question number 1C. All right, let's take a look at question 1D. It says, what is the average rate of change of the traffic flow over the time interval 10 less than a quarter t less than a quarter 15? Indicate units of measure. Okay, so before we do this, let's go ahead and take a look at the formula for computing the average rate of change. Okay, so I like to call average rate of change AROC. The average rate of change of a function f is always over an interval. It's basically the slope of the secant line. Okay, so that's f of b minus f of a divided by b minus a. It's just like y2 minus y1 over x2 minus x1, same thing. Okay, so it's the slope of the secant line. You don't need calculus for average rate of change. All right, so this is what we are calculating here. So we're looking for the AROC, average rate of change, of what? AROC of the traffic flow. So the traffic flow is f of t. All right, so you always want make sure you identify the correct function so you don't mess up the setup. All right, so let's go ahead and do it. So we're looking for the AROC of f of t over the interval 10 to 15. All right, so in this scenario, A is 10 and B is 15, and F is uppercase F of 15, okay? So we're going to look at F of B, which is F of 15, minus F of A, F of 10, divided by 15 minus 10, divided by 15 minus 10. And this will help us find what the average rate of change is. So since we already have f stored in our calculator, we're just going to take advantage of that so we don't waste time. So I'm going to go ahead and call it up. Oh, I don't have to do that. So this is what we're going to do. Parenthesis f of 15, close that, minus f of what? F of 10. Close. Now that's the numerator. The denominator is 15 minus 10, which is 5. Okay, then I'm enter to get an approximate result. So we have 1.5175. Okay, so we're gonna get 1.5175. Now, We are also asked to indicate units of measure. So what's the unit of measure here? All we just have to do is look at the numerator and then look at the denominator, look at what the units are, and then we can figure out what the unit of the final result is, okay? So the numerator is the flow rate, the traffic flow rate, okay? So the traffic flow rate, as indicated originally, is in cars per minute. So we're looking at cars per minute for the numerator, and then the denominator, 15 and 10 are times, right? And the unit of time and this problem is minutes. So let's resolve this units right here. It looks messy. So you have cars per minute over minute. So you can just write a denominator, put over 1. And then you're going to have 1.5175 cars. You just drop change flip, okay? So you drop the top unit, multiply by the reciprocal of the bottom unit, like that. And then you have the final answer, 1.5175. And the numerator for the unit is cars, and then the denominator is minutes square. Bam, okay? So go ahead and box your final answer so it's easy to grade. In this problem, you get a total of 1 point for your correct answer with the right units. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you find the contents of the tutorial helpful in your preparation for the upcoming AP Calc exam, please give us a thumbs up. Your positive feedback is very valuable to us. Any questions or comments, just indicate it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to the remainder of this review series and other great AP Calc preparation material. More content can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.